is the meaning of matter? Matter is anything that has mass and occupies space. Anything that has mass and occupies space is matter. And if you look at our environment, you can find so many substances ranging from living things to non-living things. So everything that you can see in your environment and the things that you can feel and interact with in your environment are all what we know as matter in chemistry. Then we have states of matter. And these states are solid, liquid, and gas. Now, each of these states have their examples. For example, solid state could include your book, your pen, the food that you eat, depending, solid food that you eat, biscuits, human being, plant, table, and so on and so forth. Then liquid include blood, water, drinks, petrol, and kerosene. Then gas include oxygen, hydrogen, the cooking gas I use in cooking. All right, so these are all examples. Each of these states of matter have their characteristics features. Each of them have their characteristics features. For example, solid has solid states has definite volume and definite shape, and the reason why it has a definite volume and shape is because the particles are packed together in their crystal lattice. So because they are packed together, it helps the particles to interact or bond very strongly with each other, thereby giving us a definite shape. All right, but when you come to liquid has a definite volume. Okay, we can measure the volume of liquid. You can say that it is 1 liter, depending. But for shape, liquid does not have a definite shape. The reason is because any container that you pour a liquid into, the liquid will assume the shape of that container. Okay, that is why we have sachet water. If you pour it into, depending on the shape of the sachet that you pour it into, it will automatically take the shape of that container. Whether you pour it inside a square shape, oval, triangular, whatever the shape is. And the reason why liquid does not have definite shape is because the particles are spread apart. They are not as compacted together as that of solid state. Now, when we go to the gaseous state do not have definite volume. It does not have definite shape, and the reason is because the particles are very, very spread, very, very well spread apart. So it is basically impossible for you to gather the particles together. They have, ability to move freely, and that is why we cannot even see gas. Okay, but we can feel the effect because they're always in motion. They're always, moving about. Having said that, do you know that each of these states of matter can actually change or transform into, from one state to another? All right, that is the beauty of science, because whatever we do in science, we also have explanation or laws that back it up. Okay, so basically, solid states of matter can change from being a solid into being a liquid, and liquid can also change into gas, and gas can even change into liquid, and vice versa. So there are two basic conditions that can make this to happen. The first one is addition of heat or heating. Okay, so these are the basic conditions that can make that change of state to happen. So for example, when you add heat to water, when you heat up water, water begins to gain energy. The energy from the heat will now get into, or get into the molecules of the water, and then as time goes on, it will begin to boil, and as it boils, it begins to vaporize. So that is a good example of water changing from liquid state to gaseous state. Likewise, when you put water in a refrigerator, it will change from liquid into solid. That is, it will freeze, okay, and become ice. And then when you bring it out again from the fridge and then allow it, in the environment, or you heat it up, it will now melt back into liquid. So these are, the two conditions that can make any state of matter to change into another state. Now, all the changes in matter can be grouped into two. So we have physical changes and chemical changes. Physical changes are those changes that no new substance is formed, okay? And because no new substance are formed, they are easily reversible. You can change it back into what you began with in the first place. Unlike chemical change, in chemical changes, new substances are always formed, and because of that, they are not easily reversible. Freezing of water, melting of wax, evaporation of water, and so on. But chemical changes, like I said, chemical changes are those changes that new substances are always formed, and because of that, they are not easily reversible, just the opposite of this. Chemical change is a change in which new substance is formed and is not easily reversed. We have burning of substances, fermentation, rusting of iron, decay of substances, and so on and so forth. There are so many. We also have other ones include addition of water to quicklime, the changes that take place in the electrochemical cell. All right, let us compare physical changes and chemical changes. These are the comparison. In physical change, there is no new substance that is formed, whereas in chemical change, new substance is always formed. Remember the examples I gave. For example, when you melt ice, there is no new substance that you form. What you had earlier was water, which is a solid water, which is ice. Then when you melted it, you now had liquid water. All of them is still water, so you do not form any new substance. But when you look at chemical change, when you burn a pepper, for example, you will never have that pepper back, because the pepper will change from pepper into ash, and then some will even be into ash, and then gas, smoke, it will just change to new things. So that is the meaning of this first one. Then the second one is that physical changes is easily reversed. When you freeze water, you can change it back into liquid water by heating it up. All right, but when you burn pepper, there's no way for you to change the gas, the ash, the smoke back into pepper again. So chemical changes are not easily reversed. Then the third one is that there is no change in mass of the substance. Remember, if I take a cup full of water and pour it into a container and freeze it, my water remains intact. There is no change in the mass, because what I started with is conserved. Unlike chemical changes, when I bring, let's say, a pack of pepper and burn it, after burning it, part of the mass of that pepper will be lost as smoke, part of it will be lost as gases. Others will even be lost as, even the ash self will diminish the mass of the paper. So when you weigh it, it will no longer be the mass, that you started with, that, that you have at the end. Then the last one is that there's no great heat change that is involved in physical change. Whereas in chemical change, a great heat change is always involved, okay, because we are forming a new thing. So a great heat change is needed to either speed it up or make it to happen. All right, so a quick recap. Remember that we said that matter is anything that has mass and occupies space. And then we have these three states of matter, which are solid, liquid, and gas. Their examples are numerous, okay? Then we also have two basic conditions that can make any form of matter to change from one state to another. We said that those two conditions are either heating or cooling. All right, then we now have two types of changes that can take place in matter. Those two changes are physical changes and chemical changes, and these are the comparison of the physical changes and chemical changes. Now remember that we said that in physical change, that new substances, there's no new substance that is formed, and that change is easily reversed, unlike chemical change. Chemical change is actually the opposite of physical changes. Thank you very much for coming to class today. I hope to see you in the next one. Bye for now.